the derivative of x, which is just 1. So if I plug into that, I'm going to get e to the k for my slope. So we're going to have y minus e to the k equals e to the k times x minus k. Alright, so this is going to give me y minus e to the k equals e to the kx minus k e to the k. So if I solve that for y, by moving that e to the k over, this is what I get. Yeah, this is kind of a pain. Because once you get the derivative, you plug in ordered pair. The only place, though, that we can plug in is just the x, so I plugged k in there. Alright, so this is the slope of the line. Alright, which means that the rest of this is the y-intercept. So we want this to equal 1/2. Alright. The number in front of your x is the slope. So everything after the x is the y-intercept. So we want to know, where does this equal 1/2? And probably the easiest way to figure it out is to graph this using x instead of k, and then graph 1/2 and see where they intersect. So let's see. This problem is deceptively hard. Seems like it's not going to be that bad. So negative x e to the x plus e to the x. Now I'm going to use x instead of k, because k is the variable. That's what I'm looking for. So I'm going to use x. Negative x e to the x plus e to the x. And then I'm going to graph 1/2. Now I'm looking negative x e to the x. Well, we're not putting in the first part, right, because we don't care about the slope. All we care about is the part that's the y-intercept, because it says, what value of k would the y-intercept be 1/2? So we want to know this part that's the y-intercept, what would it equal 1/2? So we're going to put the part that's the y-intercept. We put the part that's the y-intercept in F1, negative x e to the x plus e to the x. And then we put 1/2 into y2. And I'm going to do menu, analyze graph, intersection. And we only want the positive value, so I'm just going to find this point of intersection over here. So 0.768. 0.768. Which is B. Yeah, when we first started out, I thought the problem was going to be easy. But it wasn't really. It was pretty tricky. All the e, k, x, y, you got so many variables and stuff going on, it's kind of a mess. So this is slope. This is y-intercept, and we want the y-intercept to equal 1/2. So we want to know, where does this equal 1/2? Anytime you want an equation on the calculator section, you can just put one side of the equation into y1 or f1 and the other side into f2, and then just look for where they intersect. Menu, and then 4, and then number 1. If you want to just do a standard window, you can just do menu 4, and then zoom standard. We'll just do like a standard viewing window. Good Lord. Alright, number 87. A differentiable function f has the property that the derivative is less than or equal to 3 for all x's between 1 and 8. And f of 5 is 6, right? So they give us that f of 5 is 6. And they want to know which of the following could be true. Could f of 2 be 0? Could f of 6 be negative 2? Could f of 7 be 13? Right. So it's kind of like that when we did a minute ago. We have like a table of values, and we know that the slope, or the derivative, between any two values has to be less than or equal to 3. So if I look at the slope between 2 and 5, that would be, it goes up 6, it goes up 3, 6 over 3 is 2, and that is less than or equal to 3. So it is possible for f of 2 to be 0, because that would make the slope between those 2 points, which means it would also make the slope at the points possibly be 2, which is something less than 3. And if you do the same thing here, this goes down 8, and this goes up 1, up 1. So negative 8 over 1, that is also less than or equal from 7. And 5 to 7, that's 2. 7 over 2 is 3.5. And that is not less than or equal to 3. So it's possible that the slope between 5 and 7 is more than 3. Because the slope, or the slope at those points, right? Because the slope between those points is more than what the slope at those points should be. So the only that are possible are 1 and 2. Because you have to use the point they gave you. We're checking these other ones, right? So I had to use 5 and 6, because that was the only one that I knew for sure. And then I'm checking the other ones against that. Does that make sense? Yeah, you have to use 5 and 6. See, some of these are not hard, it's just the way that they're worded. It's not what you're used to. It's not what we really talked about when we talked about this stuff. Alright. 88. The graph of the differentiable function f is shown in the figure above. Let h be the function defined by integrating f. Right? So if we would integrate f to get h, that makes this the derivative of h. Which of the following correctly orders h of 2, h prime of 2, and h double prime of 2? Okay, so they're listing them from smallest to biggest. Right? If you look at these, so they want to put these in order from smallest to biggest. So h of 2 is what we would get if we integrated this function from 0 to 2. Right? And that's what this says. This says h is the integral from 0 to x of f. So h of 2 would mean we would integrate from 0 to 2. So h of 2 would be the area from 0 to 2. H prime of 2 would be the y value at 2. Right, because remember, if I'm looking at this, this is the graph of the derivative of h, since I integrate it to get h. So the derivative of h at 2 is just the y value on this graph at 2. It's 0. And then the second derivative of h at 2 would be the slope of this graph at 2, which is negative. So positive h is a negative slope, right? So if we would integrate it, if we integrate this to get the function, that means that this is the derivative of the function. Integrate means find area. This is positive area. The derivative is the y value, which was 0. And then the second derivative is the slope of the derivative, which was negative. So if I go from smallest to biggest, it's derivative, first derivative function. So second derivative, first derivative function in BE. Right? Negative, 0, positive. We're going to skip 89. Y'all don't know how to do that yet, but that's related to the other one I told you to skip a minute ago. We're going to have to do both of those later this week. I like it to be one of the last things we do because it's pretty easy and it's always one of the free response too. A particle moves along a line that its velocity is given by. For what values of t is the speed of the particle increasing? So remember, speed is increasing anywhere that velocity and acceleration have the same signs. Alright. So if you were to graph the velocity equation, you're looking for where the y values, or the velocity values, and the slopes, which are the acceleration values, have the same sign. So above the x-axis with positive slope, below the x-axis with negative slope. So we're going to graph this equation starting at 0, and we're going to look for that. We're going to look for where the y values and the slopes have the same sign. And we're going to use x instead of t when you graph. Alright, so I'm going to graph cubed plus 2x squared plus 2 to the negative x. I'm going to set my window to start at 0. Alright, so positive y values with positive slope, and then negative y values with negative slope. So it has positive y values and positive slope starting wherever this minimum is all the way to this maximum. And then it has negative y values and negative slope starting wherever this 0 is. So we're going to find the minimum, the maximum, so we know what those 2 points are, and then we're going to find the 0. We'll get to lots of analyze graph. So menu, analyze graph. I'm going to do the minimum first. I'm going to start here. Oh, maybe it starts at 0. We may need to go a little bit, make our graph, make our window start a little bit to the left hand side, so we can see. Okay, no, the minimum is at 0.176. Good grief, yes, got it. 0.177, alright, so it's got to be D or E. Oh, it's got to be E, because I know there's 2 intervals. Alright, so just finding that first one helps us. So from 0.177, we're going to assume that's 1.256, and then from 2.057 on. Right. So positive slope, positive y values between those, between the minimum and maximum, and then negative slope, negative y values starting at this 0. Alright, so it would be E. So we really didn't have to find all the points. We could figure it out after just the first one. So that's kind of nice. Alright, we're almost done with the 2014. Just have a few problems we'll have to come back and pick up later that we had to skip. Alright, 91. Let f be a function defined for all real numbers so that the derivative of f is positive and the second derivative of f is positive. Which of the following could be a table of values for f? So we've already done a couple like this. If the derivative is positive, right, it means that your y values have to be increasing. Right? So it can't be A or E. Because on A and E, the y values decrease at least part of the time. Right? So positive slope, or positive derivative means positive slope. It means that your function's increasing. And this one, it goes down 1. When the x goes up 1, then it goes down 2, then it goes down 3. Alright, so the slopes would be negative, so it's not A. The same thing happens between a couple of the points on E. Right? It goes down 1, it goes 3. So the slope's negative at least once there. Right? So these 3, the slopes would all be positive. This goes up 2, up 4,